How to rebalance a binary search tree. Welcome to Programming Corner. In this video, we are going to discuss about how to rebalance a binary search tree for minimum possible height. Make a note that binary search tree is a binary tree with a condition over how its nodes are arranged. In this example, numbers less than the root node are inserted to the left subtree and numbers greater than or equal to the root node are inserted on the right subtree. So, given a binary search tree with height equals to 4 on the left, how can we reorder its elements to have a minimum possible height, the one on right with height 2? Before that, let me quickly explain you in-order traversal on a tree. In-order traversal follows traversal pattern of process left subtree, process root, and then process right subtree. If you perform in-order traversal on binary search tree here, you will get numbers in sorted order 50, 75 and 100. We can use this property of binary search tree. Once we have sorted array, we can recursively split it into two halves with middle element as root. For our example of right skewed binary search tree with height 4, the in-order traversal will generate sorted array as 25, 50, 75, 100 and 250. Make the middle element 75 here as root. Split the array into left and right halves. Next, we split each subarray into two halves, keeping its middle element as root. We do this until we are left with one element in subarrays. This way, we will have balanced tree. Let's have a Python code walkthrough. The class node represents a node in a binary search tree. It holds the data, left and right child. The insertBSD function inserts a node from a root of given binary tree or a subtree. If the node's data is less than the root's data, the node is inserted into left subtree. Else, the node is inserted into right subtree. The method inOrder performs the inOrder traversal from given root node and stores the result into inOrder array. As I mentioned earlier, we first process the left subtree, then the root, and finally right subtree. If left subtree is not empty, we recurse on left node. Same is the case with right subtree. The extend method in Python simply merges the returned in-order traversal of subtree, and finally we return the entire array. The method create balanced tree from sorted array recursively splits the input sorted array into two halves and creates a balanced binary tree. As you can see, at first I am calculating the mid by length of sorted array, and the middle element would be the new root. The left half of the array would be the left child or left subtree of the new root, and likewise the right half of the array would be right child or right subtree of the new root, and finally it returns the new root. Now let's see the code in action. In main definition, I am creating a root node with value 25. After that, I am creating right skewed tree with a root node as 25. As you can see its structure in comment. The in-order array stores the in-order traversal of that particular tree. At this point, I am printing the height of tree. After that, I am calling a method create balanced tree from sorted array by passing the in-order traversal of our previous tree. And our new root will be stored at balanced tree root. It will be something like the one in second comments. And at last, I am printing the length of new subtree. As you can see from terminal, initially the height of the skewed tree was 6. After rebalancing, its height reduced to. I hope you liked this discussion, guys. Like this video, share with your friends and subscribe to Programming Corner.